Hi! For the second day of our Congruent Triangles chapter, we're going to talk about midpoints and bisectors. So we're going to start off with just a new term that you probably haven't seen before, and that's a midsegment. In a triangle, the midsegment connects two midpoints. So it's a segment that connects two midpoints. So a midsegment is a segment that connects two midpoints. So on the next page, what we're going to do is construct a triangle. So make sure you click down in the bottom box, and then we'll go to Menu, Shapes, and we'll just start with any random triangle. So just click in 3 spots to get a triangle. And now what we're going to do is put mid-segments on those two sides. So we'll go to Menu again, choose Construction, and we want a midpoint. So I'm going to point to all 3 sides. So there's one midpoint, there's another, and there's another. Now, if I connect two of those midpoints with a segment, I have a midsegment. Now, what I want to do first is go ahead and measure. I'm going to measure the length of the midsegment. So I want to measure the length that goes from there to there, and that's 14.19. And then I'm going to measure the length of the side that's parallel to it. So I measured the midsegment, and I measured the side that it's parallel to. And what you should notice is that that midsegment is exactly half of the side that it's parallel to. So every single time that you have a midsegment, it's going to be half the length of the side that it's parallel to. Now, we have another midpoint on there. What I wanted you to see is that there are more than one midsegments on a triangle. So I can connect those two midpoints, and that's a midsegment. That midsegment is parallel to this side of the triangle, so this should be half of the side it's parallel to. And then there's another one that goes from there to there. So if I go in and measure the length of my 3 midsegments, and then measure the length of the 3 sides of the triangle, we should see that the midsegment is always half of the side that it's parallel to. So this 7.29 is across from the 3.64, so that's half. And the 1.87 is across from the 3.75, that's half. Now, one thing that I just want to have you think about for a minute. If we wanted to find the perimeter of this tiny triangle that's made up of all of the midsegments, what do you think the perimeter would be of that triangle? Well, it would actually be half of the perimeter of the big triangle. So all the midsegments are half of all the sides, which makes sense that then the perimeter would be half of the perimeter of the big triangle. Okay, so the relationship. In a triangle, the midsegment is half of the side that it's parallel to. So as a formula, midsegment equals half of the side that it's parallel to. Alright, regions question, just so that you can see how they could ask this on a problem. In triangle ABC, ED connects the midpoints of AB and AC. The length of ED is 8. What is the length of BC? Well, if ED is 8, BC would be 16. So 16 would be the length. Now, one other thing that I just want to make sure that you understand. What we end up getting here when we have our midsegments is we end up with a tiny triangle on the top and then the great big triangle down here. And if that segment, the midsegment, is parallel to the opposite side, what we end up with right here are 2 corresponding angles. So angle AED and angle ABC are corresponding angles. And in the last chapter, we actually learned that those corresponding angles are equal. So what I want to do is measure AED and ABC, and they turn out to be exactly the same size. Same is true on the other side. Angle ADE and angle ACB are going to be exactly the same size also. So we have corresponding angles which are the same size. Okay, another regions question. This time we're told that we have triangle ABC, DE connects the midpoint, so that's our midsegment, and we're told that DE is 3x plus 4, and BC is 8x minus 2. So, what you want to think of for this one is that the midsegment is half of the side that it's parallel to. So, the midsegment is DE, that's the 3x plus 4, and that's equal to half of the side that it's parallel to, which is BC, which is 8x minus 2. So basically, you take what you know about the problem and you plug it into an equation and then go through and solve for x. So multiply everything by 1/2 and then combine your x's and your numbers and solve for x. Okay, second part of this is bisectors. Angle bisector is a line or a segment or a ray that cuts an angle in half. Perpendicular bisector cuts a segment in half and forms 90-degree angles. Now, those are all words that we've used quite a bit this year in this class, so hopefully that's review. Now, what I want to do here is construct an angle bisector and measure the angles that are formed. So, I'm going to construct an angle bisector, and you can pick whatever angle you would like. And then I want to measure the angles that are formed. So I'll measure the angles. So one right there, and then the other one right there. And what should happen is that those two angles turn out to be exactly the same size, which makes sense. That's why it said that they were cut in half. So the other thing that I want to mention is that these two angles together add up to the great big angle. So if I measure the great big angle, I get the 72.3. So those two tiny angles together add up to 72.3, and each one is exactly half of the 72.3. One thing that I just want to look at, what if I were to measure the length of the sides down here? Are they the same length? Well, if I measure from there to there, I get 4.65. And if I measure from there to there, I get 10.3. So what I want you to see there is that with an angle bisector, you cut the angle in half, you're not cutting the opposite side in half. Okay, next thing we're going to do is construct perpendicular bisectors. I guess we'll just do one. So for this one, construct perpendicular bisector, point to one of the sides, and there's your perpendicular bisector. Now, what I want you to see for this one is that the side is being cut in half. Okay, so that side is being cut in half, and we should have a whole bunch of 90-degree angles. So if I measure the angle formed right there, we get 90 degrees. Alright, the last thing that I want to do is go back to the angle bisector picture. So if we go back to the angle bisector picture, what if I draw in all three angle bisectors? This point right here where the three angle bisectors meet is called the incenter. What I'm going to do is just put a point there. Okay, so that's the incenter. Now, another thing that I just want to make sure that you see, if I construct something perpendicular to this side through that point, and to this side through that point, and this side through that point, okay, I end up with these new segments. Okay, so what I did is I went through and measured those three perpendicular segments that go from the incenter to the outside, and what you should notice is that they're all exactly the same length. So you have your angle bisectors, which cut the angles in half, and then you get the incenter, which is that one point where they meet. If you draw perpendicular segments from the incenter to the outside, all of those will be exactly the same length. Basically what you have there is a circle that is inscribed in the triangle, and all of those perpendicular segments are the radii of that circle. Okay, so at this point all you really need to understand is that all of those perpendicular segments are going to be the same length. Okay, so that's it for today for day 2.